This is how we draw the batteries in the diagram. Next up, some misconception we need to address. Many students tell me, hey teacher, battery actually store electricity, right? Well, the answer is actually wrong because battery don't store electricity, batteries store chemical. So when two ends of the battery are connected in a closed circuit, this chemical inside the battery will react to produce electricity. So all your battery you see in the market, inside them is all chemical, not electricity. They must react to produce electricity, all right? Next up, when we have battery, we definitely need to have wires. So current normally flow through the wires that you can see from the picture here, all these wires. And all these wire materials are usually copper because copper allows the current to pass through very easily. And to protect us from getting shocked by the electricity, we cover the wire with materials such as plastic or rubber to prevent this current from leaking out of the circuit. This to prevent any hazard while using them. So in a diagram, how we draw the wires, we draw straight line. So you can see here, this long and short line represent the batteries, the plus side and the minus side, the positive and negative side. And this red color straight line, it shows the electrical wires. All right. Next up, there's some misconception on how the student gonna draw. Usually for this chapter, right, in all examination, they will definitely ask you to draw something. When they ask you to draw something, they ask you to draw the wires and draw the light bulb. So many students say, teacher, your picture show me that the wire is curvy, not in straight line, so I must also draw curve lah. Like for example, this picture is like a circle shape. So I must draw like a circle, like oval circle shape. Am I right now? In this case, you are wrong because your drawing of the wire must be in straight line regardless how curvy the wire appears in the picture. So even though this picture you see is one look like an oval, but however, in your diagram you are going to draw for examination, you must draw in straight line like this as shown here, with a battery followed by the wire, light bulb, and a switch here. So battery, switch, light bulb, all in a straight line. All right. So please take note on these important things. Next up, switch. In every circuit, there must be a switch to control the flow of current in a circuit. This switch, right, either breaks or complete an electrical circuit. So when you open the switch, there's a gap. Look at here, there's a gap here that or the break between in the circuit. Therefore, electrical current cannot flow through. When it cannot flow through the wire, the light bulb will not light up. However, if I were to close the circuit like this, the closed switch, the current can actually flow through the switch and therefore the circuit is complete, so the light bulb will light up. This is how we determine whether should we open or close. When we open, the bulb won't light up. When we close the switch, the bulb light up. All right. So how does this, so let me go into details on how does this current flow in a circuit, all right? As mentioned earlier, we have close and open. Close means the switch is closed, everything is connected. Open means there's a break in between, the circuit is not connected, there's a gap in between. So let's look at closed circuit in this diagram here. This current from the battery can only flow in a closed or complete circuit, all right? So when all the components batteries, light bulb, wires are joined to form a complete path, one loop here. This is called the closed circuit because the current can flow through them in a circle, in a loop. There's no gap. This is a closed circuit. So therefore, by definition, how do we explain closed circuit? We use this pointer here. In a closed circuit, electric current flows from the battery through the wires to other electrical components and back into the battery. This is called the closed circuit. Like I mentioned earlier, this circuit can only be complete when all components are properly connected. So you can see that the battery is minus, plus, minus, plus, minus, plus. Then the current flow through the wires. The wire connect the metal tube and the metal casing on the bulb and go back to the battery. This completes the loop. Therefore, we call it a closed circuit. Next up. So when we talk about closed, we talk about open as well. So open circuit. So when all the components of a circuit are not properly connected, there may be a break or gap in a circuit. So when there's a gap or break, right, current cannot flow through. When current cannot flow through because current cannot pass through the gap, this particular circuit is broken. Therefore, this circuit is an open circuit. So we use a switch to either close or open a circuit. Look at the diagram here. We have a switch here. When we connect them all together, join the wires in one straight line, the light bulb light up. However, when we open the switch, there's a gap in between, the light bulb don't light up. This is how we determine a closed and open circuit. All right, let's carry on. Now, look at the light bulb. Light bulb is a device that we often use in a circuit to see whether is there any current flow through in our experiments. When the light bulb light up, means current flow through. It's a closed circuit. However, when the light bulb don't light up, that means there's a gap in between, or there's something wrong with the batteries, or the bulb is spoiled. All right. So how we draw the light bulb in the diagram? There are two ways. One is this diagram here, and another one is a circle with an X. The most common standard drawing is a circle with an X. This is how we draw light bulb in a diagram. So let us go through one by one. What is the bulb? What's the parts that make up a light bulb? First, we have the glass. Number one here, the glass bulb. Then number two, inside the glass bulb, we have the low pressure gas such as argon, nitrogen, krypton, and xenon. Then we have number three here, the tungsten filament, where it will light up from here. Number four, we have this green color that goes out of the stem. Number five, we have this wire that goes into the stem. Then we have support wires, number six, support wire here. Then we have number seven, the stem here. Then we have number eight, the contact wire that got a stem, followed by number nine, the cap. Number 10 is the insulated insulation, and number 11 is the electrical contact. Students always mix up by saying that, teacher, so many will say, right, I must make sure that the wire are connected to point number 11 and point number 8 in order for the current to flow, right? If I connect any other place, right, the current won't flow, right? The answer is actually not true, because number 9, the cap is actually an electrical conductor. So even though the light bulb don't light up, but if we put two wires on the cap here, current still flow through them, because number 9 is an electrical conductor. It allows electricity to pass through. It's just that the light bulb won't light up, but current still pass through as a complete circuit, because number 9 is a conductor of electricity. So if I were to put two wires and a battery that connected to here, this part here, number 9, current still pass through. It's just that the light bulb won't light up. The light bulb will only light up if one wire put at number 8 and one wire put at number 11. Then the light bulb will light up. All right, let's carry on. So, how do we connect? So a light bulb will light up when we use wires to connect it properly to a working battery. The key words here is a working battery. So if you were to put a battery that's dead or spoiled, the light bulb will not light up. There are two ways to connect to a bulb to a battery. So number one, the first one here, where I put the tip at the plus sign, then I put wire at this side and close the loop here. The other way is I put the battery on the side of the bulb and use the wire to close the loop. So when the metal tip and the metal casing of the bulb are connected to different end of battery, the bulb light up because it completes the circuit for the current to flow between the ends of battery. Current must flow from the plus sign to the negative sign of the battery in order for the circuit to be complete. If you put the wire at any points, the battery will not be able to complete the circuit. All right. Next up. Just now we talk about how the bulb light up. Now look at the bulb will not light up. There are two ways. Number one, either the metal tip or the metal casing is not connected to the battery. Number two, the bulb blow because too much current flow through it and the filament melt. When the filament melts, there's a gap. When there's a gap, current cannot flow, therefore the bulb cannot light up because it's already spoiled. The gap. All right. So you can see that I put like this. I put two sides towards the side. Current flow through, but the bulb will not light up. Same thing here. I put a tip here. Current flow through, yes, but the bulb will light up because this is not connected. So this is there are three different ways on how the bulb will not light up because of gap. All right, let's carry on. So, having said that, in my diagram here, will the bulb light up? Any volunteers want to try this question? Will the bulb light up? Yes, David. Oh, I can't unmute you. Please unmute yourself. David, I can't unmute you. I'm not the host.
I think that the bulb will light up.
Which bulb? A or B?
Both of them.
I understand. Okay, in this case, right, A will not light up, but B will light up because for A, yes, wire connect to the metal casing, but metal casing is a conductor, so current flow through the metal casing. However, in order for the light bulb to light up, one wire must connect to the bottom of the light bulb. So for this A, current flow through, yes, but not flow from up because this wire must go down in order to flow up. So therefore, A will not light up, but B light up because B connected from the bottom and then it travel up and go down from the side. Therefore, in this case, A and B, A will not light up, B light up. All right, let's carry on. This is some of a diagram that you draw in your these are some of the symbols that you draw in your diagram. For batteries, always remember the longer line is always the positive side, the plus side, whereas the shorter line is the minus negative side. So this is one battery symbol. If you have two batteries, you draw two times. All right. if you want to draw a light bulb, we use a circle with X, open switch, the switch open with 2 circles, close switch with 2 circles. You can either use square or circle to represent the end of the switch. So some students use square, some students use circle. Either way is fine. As long as you show the teacher that the line is either diagonal or straight. Diagonal up for open, straight line connected, both dots is close. All right. Now, after going through the component, going through the different type of component in a system or in a circuit, we talk about open and closed switch. Now it's time to look at the different type of circuit. We have 2 different type of circuit. One is a series circuit and the one is a parallel circuit. A series circuit, how do we know which is which? The series circuit basically means that all the components are connected end to end, one after another. They make a simple loop for the current to flow around. So basically means, right, if you see a rectangular shape in your diagram, only one rectangle shape in your diagram, like this, where 1 battery and 2 light bulb, 1 rectangle complete shape, where with all the components, the light bulb in one straight line, this is known as a series circuit. There's one big problem for this circuit. If one light bulb blow, there will be a gap, and therefore it will break the whole circuit, and all the components, all light bulb in this series circuit will go out. So no light bulb will light up if one goes off. So this is a downside for a series circuit. Next up. However, parallel. Parallel means, right, in one rectangle in your diagram, there's line cutting across in the middle. Like for this case, I have one rectangle with one line cutting in the middle, component connected side by side. All right. So these components are connected side by side. The current has a choice of route or path. So if one light bulb blow, there will still be a complete circuit for the other bulb to stay lit. Meaning to say, if example we have A and B, A is the middle one, B is the outside one. If A, the bulb blows, there's a gap or break here, this light bulb will still be able to light up because it still form a complete circuit. Even though there's a gap here, the current can't pass through here. However, current still can pass through the outer layer, outer lines. Therefore, if one bulb blow, the other still can be lit up. Therefore, parallel circuit is often used in many places so that to ensure the system works. Okay, so this is how we draw the circuit. So for this series circuit, we have one complete lines. You draw one battery and one light bulb. And bear in mind that even though the wire is in a circle, your diagram must use a ruler to draw a straight line. So this is a simple diagram to show light bulb and battery. One light bulb, one battery. If one battery, 2 light bulb, same theory here. One battery, 2 light bulb, use a ruler and draw one straight line. For parallel circuit like this, you have one battery, the first loop, and another light bulb in the second loop. So in this case, the diagram will draw 2 rectangle or one rectangle. In the middle, we cut one line across to draw a light bulb. This is called the parallel circuit. So, series and parallel circuit. Therefore, in summary, the series circuit, the electrical current only have one path to flow. So only have one path to flow. If any of the light bulb blow, the circuit is broken. Current cannot flow through them. For parallel, there are multiple paths for the current to go. So you have, even if this is broken, I still have this one and this one to proceed. All right, this is how we determine between series and parallel. So when the electricity have to flow through one part to get to another part, like a series circuit, there's a problem. More component means more resistance. When you have increased resistance, right, your current there's a decrease in the current flow. When there's less current, there's lesser your light bulb will appear to be less bright. So therefore, as voltage increase, current increase. And because there's too many light bulb in a circuit, they're causing a lot of resistance, your light bulb will be light up, but at a less bright. All right. So example like this. The problem is because there are many devices here, there are less current passes through them. Therefore, the light bulb will appear to be less bright compared to one light bulb. So in one light bulb, the light bulb is very bright, but two light bulbs sharing the load and too much resistance. Therefore, you can see that two light bulbs in one circuit is very dim. And if one light bulb break off, the entire circuit is gone. So this is a problem with the series circuit. All right. So what is this resistor all about? Resistor is basically to resist the flow of the current. When we increase the resistance, it will reduce the rate at which the charge flow. Therefore, the light bulb will getting dimmer and dimmer. We keep on adding light bulb onto the circuit. All right. Next up, current. In a series circuit, current is like a flow of water. Like water go from out of a battery back to the battery itself. So it's like one current, like flow of water flowing from this side all the way to another side to complete. And this current cannot disappear. It will continue to flow. Since there's only one path, this current will flow and pass through the light bulb central, and it will go through the different type of light bulb. As more and more light bulb being added, the light bulb will become dimmer and dimmer and dimmer. So this is some of the problem that a series circuit will face. All right. So therefore, because we have so many problems with the series circuit, there is another helpline called the parallel circuit. The advantage of the parallel circuit is no matter how many light bulb I put in a parallel circuit, the current will not decrease. Therefore, the light bulb, all light bulb will light the same brightness. The light bulb will not get dimmer. We know that in series circuit, the more light bulb we add, the light bulb will get dimmer and dimmer and dimmer. However, for parallel circuit, no matter how much we add the light bulb, all light bulb will light brightly because the circuit or parallel does not decrease the current, they will not dim out the light bulb. So even if one light bulb were to be burst or break, the rest will still be light up. However, there's a problem here. Current does not stay the same for the entire parallel circuit. This means to say the current will increase, energy used up faster, leads to hotter wires. When the wire get too hot, there will be a fire hazard. So this is some of the examples of the problem faced for parallel circuit. In series circuit, we are concerned if a light bulb were to burst, goes off, the entire circuit is a gap, the light bulb for the rest will not light up. However, for parallel circuit, even though one light bulb goes off, the rest can carry on shine brightly, but there's a problem here. The wire may get too hot and there may be some fire hazard going on here. So after talking so much for your left for primary 5, which is better, series or parallel? The answer is parallel is better, even though there's some hazards going on, but these are being dealt with the circuits in our home. or the circuit breaker in our home. So most things that we know of, the one that in your classroom, in your house, they are wired in parallel. Okay. So therefore, so even so you have all the wires on your ceiling, everything to show the light, the lamp, the light, the TV here and there. Even though we know that the more we plug in, there's a chance of fire is very high. However, we have fuse and circuit breaker in the house. This is used to protect us or to prevent fire in a parallel circuit. So they will turn off everything when the current moves too fast. So that's why it's safe to use parallel circuit at homes or in
Trời ơi, trong Zoom có 25 người thôi.
Okay. So one example is a Christmas tree. So for Christmas tree, right? They are using a parallel circuit. Why? Because if one light bulb don't light up, the other light bulb still can proceed. So therefore, it will be better for the Christmas tree light to be in parallel. Next up, similarly as mentioned earlier, those circuits in your house, on your classroom, on your school, or anywhere in this world, in the building, they are all in parallel because if one light goes off, the other light still can shine brightly. This is how we know that this place is using a parallel circuit. All right. Now, a little homework here. It's been a long time since we issue a homework. So, Teacher Andrew required you all to design an electrical diagram for the newly added room in a mini Barbie dollhouse that use battery to power its room. You are provided with 8 light bulbs, unlimited wires, 3 batteries, and 4 switches. You don't need to use all of the items given. So please draw an electrical diagram to illustrate how you plan to position the light bulb, switches, and wire on the ceiling of the new room, and explain your answer in the video. So this is the new room layout. We have a battery holder on the bottom here. In this room, the Barbie dolls actually sleep here. There's a bed here. The dressing area is here where the Barbie doll actually put all her clothes here, and mirror makeup here. And we have a study table here. This is a door. So given this diagram, how are you going to do this homework? One example I did is here. The battery holder will definitely place all the battery in this corner here. I have a switch here for the Barbie doll to switch on or switch off the light. I make these 2 light bulb connected because they are the same dressing room, the dressing area and a bed. Will have the same parallel. And I have a study corner light bulb whereby I have another switch here that control this light bulb. This is a sample that I want you to draw. You all can come up with your own imagination on how you're going to place the light bulb in the room, how many wire you're going to use, up to you. Where is the switch for the Barbie doll to switch on the light bulb, and why? And you have to explain why you put the light bulb here. Example, I put the light bulb on the bed here is because when the Barbie doll is tired, the Barbie doll can lie down on the bed and read books or play game, and so therefore there's a need for a light bulb to be there on top of the bed. I need a light bulb here at the study corner because Barbie don't need light to study at night. So you have to come out a video and draw out the diagram and let us know why you put the light bulb at the corner there and how many switches you're going to use. In this case, you are given 8 light bulb, unlimited wires, 3 batteries, and 4 switches. You don't need to use up all. All right, it's up to your imagination how to place the batteries, how to place the bulb in the room. What I want to see is, are you using series circuit or parallel circuit, and why you put the switch there? All right, remember students, to draw the diagram using the symbol here, the battery symbols, the light bulb symbols, and the open switch and close switch symbol. All right, I will send this. I think Dr. Duke already sent these slides onto in Zalo already. So please do up this little homework and post to Facebook. I want to take a look. All right. So we'll come to see your homework soon. Now with that, we are going to go through to do some booklet quiz. So let me just open up the booklet now. Can anyone tell me which game you want to play in the chat? Crypto, what else? Crypto? All good, crypto? All right. Okay, sure. Crypto then.
Crypto is fun.
All right, I'll put it as 10 minutes because there's 20 questions. So I'll put at 10 minutes. So let me just, okay, so host now. Let me see if I can download everyone here. Okay, you may join this thing now. Wait a while first. Alright, I'll wait for another 1 minute to restart. Oh, okay. I'll put it in the chat. My bad. I will send the link to the Zoom chat already. Please take a look. We'll start another 30 seconds. All right, let's begin. last 30 seconds. Five, 4, 3, 2, 1. Thumbs up. We have Kudos, number third. We have Sunny, number second. We have Mia. Okay, so let's go through the question one by one. Okay, look at question one. They're asking you for number of battery in this circuit. In this case, we only see one long line and one short line. Therefore, only one battery present in this diagram here. Second question, number of switch here. Same thing here. Yes, we have two light bulb here, but we only have one switch here. Remember earlier in the lesson, I mentioned that the switch can be in either circle or square. So I have two square here and one straight line. This is one circuit, one switch, one circuit switch. All right. The question is this series or parallel? Every component is joined together via one path. So therefore, one path for the current to flow, it means series circuit. All right. This circuit is open or closed because there's no gap in any part of the circuit. Therefore, it is a closed circuit. Next up, number of battery, one battery here. Number of switches, there are two switches here, one open and one closed. Therefore, it's two switches here. Next up, is this series or parallel? Every component are joined under one path, so therefore this is series. Next up, is open or closed? Because even though this switch is closed, but it's an open switch here, as long as it's got a gap in any part of the path, it's an open circuit. All right. Number of batteries, we have one, two long lines, two short line equals to two batteries. Next up, number of switch, one switch here, one open switch. Series or parallel, there are two paths. I mentioned earlier in the lesson, if there's a rectangle, if one line cut in between, it is a parallel. All right. Next up, open or close. Switch is being open, so it's open. Number of batteries, we have three long line, three short line. It means it's three batteries. The number of switches, one closed switch. All right. 15, this is a parallel circuit. Okay, because it's somewhat one rectangle cut in between. All right. Next up, open or close. It's a closed circuit. Next up, this is number of batteries. We have three batteries here. Number of switches, one switch here. Series or parallel, as a parallel circuit. Because it's more than one path that the current can flow. Current can flow either go through here or go through here. There's more than one path, so therefore it's parallel. Open or close is a closed circuit. House wires, the wire in our houses are always wired in parallel circuit, so that if one component is down, the other still can survive. Or in other words, if one light bulb is out, spoiled, the other light bulb can still shine brightly. So in a series circuit, if one light bulb goes out or the other light bulb goes out, I have a string of Christmas light and one went out. Because other lights are still working, I ignore it. Therefore, because one went out but the other still can use, this is in a parallel circuit. What happens if you add more light bulb to a series circuit? All the light bulb will get dimmer because it's only one path and there's a lot of resistance blocking it. All right. What happens if you add more light bulb in a parallel circuit? All the light bulb will stay the same brightness and will not get dimmer. All right. And that pretty much sum up what we have learned today. So remember to do the homework that are given to you just now on the PowerPoint slide. on Tuesday, I'll be sending you all the worksheet for this chapter so that we can go through next week. With that, I will end a lesson for today. I will see you next week. Bye-bye. Take care. All the best.
Thank you,
Take care.
teacher Andrew.
Bye-bye.
Goodbye, teacher.
Take care. All the best. See
Will
you.
we have the exam at the end of the course, teacher Andrew?
Yeah, every 10 weeks there will be a short exam.
Okay, great. So
Yeah,
it's another week. Yeah, today is
Yeah.
week
Eight,
8.
yes. Yes,
So
correct.
number
Now
9 and number 10 will be the
Yes.
short
Yes.
test. Yeah.
Yes, correct.
All right.
All right. So see you next week. Bye-bye. Take care.
Thank
See
you.
you.
Bye.
Cô An Dâm nhé. Bye.